One of the basic concepts that must be understood in chemistry is nomenclature, which is naming compounds. There are many types of chemical bonds, and most bonds are somewhere in between ionic and covalent. We're going to treat ionic and covalent as the kind of extreme types of bonding as we go through the different naming here. So, 3 forms of bonding: complete transfer of electrons, that's an ionic bond; electrons being shared between 2 elements in a bond, that's covalent; and then metallic bond is holding the atoms of a metal together. We're going to deal mainly with ionic and covalent in this section as far as naming, and we're going to start out actually with ionic. Now, compounds can have common names. We know that vinegar is the common name for that substance, and acetic acid is actually the IUPAC name. Now, IUPAC stands for International Union of Pure and Applied Chemistry, and it's basically a system of naming that follows very specific rules. Now, water is a substance that we don't call it by its IUPAC name, we just call it water. And ammonia is another substance that we call by its common name rather than its IUPAC name. Well, let's talk about compounds formed from ions. So these would be ionic compounds where there's a complete transfer of electrons. These particular compounds are formed when a metal and a nonmetal combine. A metal and a nonmetal. And we call the metal, when it's charged, a cation, and we call the nonmetal, when it's charged, the anion. And together they get together and they form a compound. For example, sodium with a +1 charge because it loses 1 electron, chlorine with a -1 charge because it gains 1 electron, and together it forms, when they combine, sodium chloride, and the net charge on sodium chloride is 0. The +1 and the -1 cancel each other out. So a neutral compound requires equal number of positive and negative charges. Now, one thing that must be addressed in order to write chemical formulas for ionic compounds would be the common charges that substances will take. So if we look here at this periodic table, we've labeled some of the most common charges, and notice we've avoided the center part of the periodic table, the transition metals. We'll address those particular elements later on. But notice group 1A with hydrogen as the first element, those all become +1 all the way down the group. Notice magnesium's group minus helium there at the top, those all become +2. Notice aluminum over there underneath 3A is a +3 charge. Notice that we're skipping group 4A, and we're moving over to group 5A. The first 2 elements there are -3, -3, so nitrogen and phosphorus. And then notice oxygen's group there, 6A, those are -2, pretty much all the way down. And then notice that group 7A, including the halogens, fluorine, chlorine, bromine, and iodine, those are all -1. And then notice we assign 8A a 0 charge, which means they are relatively non-reactive. Now, these charges need to be put onto your periodic table. So take out your periodic table, and above the groups, if you could please place the appropriate charges, as well as putting the charge for aluminum with the +3, zinc with the +2, silver with the +1, and cadmium with the +2. So if you could add those individual 4 elements, and then also just place the charges at the very top of the column, the +1, the +2, the -3, the -2, and the -1 there. Now, properties of these ionic compounds. The metal atom transfers the electron to the nonmetal atom, and then those 2 things are held together. The cation and the anion are held together by electrostatic forces. In other words, the opposite charges of the 2 kind of hold the compound together. Now, ionic compounds typically form what is called a lattice, which is what you see on the screen here. It's a very ordered structure where you have the positives and the negatives next to each other. The attractions between the positives and the negatives are maximized, and then the repulsions between the like charges, that would be minimized. This particular substance happens to be ammonium chloride. So ammonium is the blue nitrogen with the 4 white hydrogen, and then the chlorides are the yellow tan in the picture, and together they form the compound ammonium chloride. So let's take a look at some specific ionic compounds. If we take calcium with a +2 charge and fluorine with a -1 charge, it takes 2 of those -1 fluorides to combine with the +2 calcium for there to be no net charge. So therefore the formula for calcium fluoride is Ca, there's just one of them, and then F2, meaning there's 2 fluorines. So 2 fluorines there, -1 charge each, and then 1 calcium. Now magnesium and nitrogen's a little tricky. Magnesium is +2, nitrogen is -3. So the common denominator there would be 6. So we want to try to get magnesium +6, nitrogen -6. It takes 3 magnesiums and it takes 2 nitrogens to get a +6 on magnesium and a -6 on nitrogen. So the resulting formula then is Mg3N2. Now we call that magnesium nitride. So notice it's just the elemental name of the metal and then the elemental name of the nonmetal, but an IDE ending there. So let's take tin +4, oxygen -2. So again, common denominator there would be 4. So the tin is +4. It takes 2 oxygens, each with a -2 charge, to get a -4 total. And the -4 on the oxygen and the +4 on the tin balance each other out. So it took 2 oxygen to do that. So it's SnO2. And we call that tin oxide. Again, it's the name of the metal, and then the name of the nonmetal ending in IDE. Now notice this one has a Roman numeral in it. We're going to get back to the Roman numerals and what they signify and when you put them in, but for right now just know that tin oxide has that Roman numeral 4. Now, when we look at formulas of ionic compounds, they're determined totally by the charges once again. So if you take a look at sodium here with the +1 charge and fluoride with the -1 charge, it takes one of each of them to reach a total charge of 0. So that would give us Na, a single Na, and a single F, sodium fluoride. Now, here's a table that shows some of the common ions and their charges. Now, you have all of this on your periodic table already, but this is the list of the ones that you would be required to know. And notice that all the metals are just the regular metal name, and then notice the nonmetals have the beginning part of the nonmetal, and then the ending has been changed to IDE. Now, when you write a formula, again, for an ionic compound, please make sure that the charge is balanced. So here's basically the 3 steps. You balance the charge with the positive and the negative ions. The positive ion always gets written first, the negative ion always second. So if barium is +2, as we can get from our periodic table, you've labeled that, and chlorine is -1, it takes 2 of those -1 chlorines to balance out the barium's +2 charge. And so we write the number of the ions needed as subscripts, and it requires 2 Cl's. So the formula there is BaCl2. Now here's a learning check. So you might want to pause the podcast now and take the 3 questions that you see here and write the correct formulas. And then the very next slide then is going to have the solution. So pause the video at this point. Okay, here are 3 solutions. Sodium sulfide, Na2S, aluminum chloride, AlCl3, and magnesium nitride, Mg3N2. Now, let's take a look at naming these compounds. So let's go the other direction. The cation always comes first, so that's the metal, and then the anion. And as we've stated here before, the cation is just simply the name of the element with no change. And the nonmetal, the anion, the negative ion, is the beginning part of the name of the element and then IDE at the end. So Cl-1 would be the chloride ion. Ca+2 was the calcium ion. And when we stick those 2 together, we take out the words ion, and so CaCl2 simply becomes calcium chloride. Now let's take a look at 3 examples here. Na and Cl. So Na is sodium. Cl is chlorine. We change the ending to IDE, so we get sodium chloride. ZnI2. Zn is zinc. I is iodine. We change the ending to IDE, so we get zinc iodide. And then finally aluminum, Al, O, oxide, so oxygen and ending change to IDE, so that final compound becomes aluminum oxide. Now, once again, let's take and let's do a learning check. So take these 4 compounds and complete their names. So you might want to pause the video at this point. And then here is the slide with the solution on it. So sodium was sodium nitride, so that was nitrogen, ending changed to IDE. Potassium and then bromine, but we changed the ending again to IDE, so it's bromide. And then aluminum and oxygen, but again we changed the ending to IDE, so that's oxide. And then finally magnesium sulfide was the last compound. So name of the metal, and then the nonmetal is sulfur, and again change the ending to IDE.